Okay, so first thing to make mention of with the radicals as we go. What we're attempting to do this is going to be we're on the back of the first page of your notes, so we're in the little one right now. And so two things I always like to mention to people at the start here of things. First is, this is going to be just like when you're combining like terms, we're going to treat the radical I had to squeeze it in there. So like a variable. So when I say that, while some of you are jotting that down, what I mean is, for instance, if you had 3x plus 6x, you're like, okay, Hardy, that's easy. It's 3x and 6x. 3 plus 6 is 9. I go about my business. It's the same idea when you're adding or subtracting a radical. If the radicals are the same, and they are here, they're both 7, we're just going to combine like terms. We're going to do 3 plus 6 is 9, and leave the radical alone. And that's it. There is nothing else fancy that I'm trying to do here. We're just going to work it and do it that way. So you're like, are they always going to be the same? Because that'd be kind of easy. Unfortunately, they are not always exactly the same. Sometimes they're going to be different, so we're going to have a little bit of work to do. So if they don't match, no, I cannot just add together the stuff that's underneath it. It doesn't work that way. We're going to simplify the radical like we did yesterday, and then look again and see if we happen to have the same radical. Thank you. So, these are not the same, but all is not lost. If I go back, I'm just going to use this so we have this to reference. I got to go backwards. Okay, there we go. So we've got our perfect squares. So just like we have before, when we're trying to break down a radical, so we're trying to break down the 12, we're going to start dividing numbers into it that are smaller until we find one that goes in nice. And you probably can guess at this point which one it's going to be, but we'll play the game just to play, should make sure. So, 12 divided by 9, that's not working real well so far, but it can still change. So I'm like, okay, so my 12 is 4 and 3. So here's what we're going to do. So the 12 we just found out again is 4 and 3. We got to have one number that's from our magic list. Once we find that, the number in the magic list, second and x squared, if you want to take the square root yourself, is going to be 2. And the other one that's not perfect, 3's not in the list, stays under the radical. So you're like, okay, but what about the 3? What's up with that? Just like yesterday, at this point, that 3 is going to come back into play because it says, hey, nice to see you 2. We're not hanging out here under the radical anymore, so we can get together. So what you see here is the same as what we did yesterday. Break down the radical, multiply the things on the outside. We're done. And so we're going to do that same thing to the second one. So any number that's less than 48, Unless you know off the top of your head. And some of you, I think, seriously could do that. So I start dividing it. Ooh, whole number. 16 and 3. So I do 16 and 3. Again, what I divided by, what I get for my answer. And again, the one that's in here is the one that breaks down. So the square root of 16 is 4. Square root of 3, the 3 is going to stay underneath. Only one's going to break down. But then our pal comes along again on the outside and says, hey, 4, nice to see that you broke out. Multiply them together. And all of a sudden, this problem has taken on a different look. Because now, before, my radicals weren't the same. I couldn't do anything. But now my radicals are the same. And now it's just like the first example that we did up top. We add the numbers outside together. And we keep the radical. Don't mess with the radical anymore once they're the same. You're like, oop, that can be a lot of stuff to keep track of. It basically, again, it's two separate problems and we put them back together at the end. But we'll see more of them. I know there's only one example on here, but we'll see more of them before I set you up on your own. And so, the last portion of new stuff for today. You're like, oh, the rectangle's back. Okay, we're looking for perimeter, which again just means add up the like terms. So I'm going to work my way around. I'm going to be like, all right, plain numbers all the way around. Nine plus 2 is 11. Plus 9 is 20. Plus 2 is 22. Just like it is with a variable, all these square root of 5s, if there's not a number in front, we assume there's a 1. So, but they're all square root of 5. So just like if these were all x's, I can add them together. So I got 3, 4, 7, 8 square root of 5s. But here's where I got to be careful. There's going to be a temptation out there that when I get to this, you're like, oh, well, 22 plus 8 is 30. It's 30 square root of 5. Remember, we treat the radical like it's an x. If this was 22 plus 8x, you wouldn't put them together and call it 30x. I hope not. And so, that's as far as I'm going to be able to get. Because again, treat the radical like it's an x. Because we know variables, and we just don't want to make this overly complex. So, keep that close. Because now I got to flip back here. We're going to be using this to help us out here. Pages 7 and 8. So, as you look through this first part, the whole first section, we're happy about this. The radicals are the same. However, do pay attention to the sign in the middle. Because if it's not plus for all of a sudden, this is 6 minus 8. Do not be afraid if you need to go to, to go to the calculator. But leave the radical alone. We're just combining like terms. Once you get down below, though, now we got to start thinking a little bit. When we get down here a little further, let's say we do 8. Yeah, let's do 8. So I'm looking at 8. Now that I have access to being able to use my notes, this is going to be a little easier. Okay, so there's the front of my notes. There's my perfects. I'm going to start working. If colors work better for you to separate, I'm all for it. So again, just like we have before. And I swear, some of you are going to start seeing some of these patterns, and you're going to start doing these faster. Whoops. But until you do, just start dividing those numbers into 50, starting with the biggest, until you get something that goes in nice. 25 and 2. Square root of 25 is 5. The calculator can do it, or you can. It doesn't matter. And then we do the same thing with the 32. Again, 36 is bigger than 32, so I don't need to look at that. And I'm just going to start dividing them in again. Okay, that one didn't work. That one did. 16 and 2. Look for the one that's in your perfect box here, the 16. That square root is 4. Or if I wanted to check in the calculator, again, second and x squared will get me the square root. And I can do it that way. And hey, they're the same, so this works out well for me. So, 5 minus 4 is 1. Square root of 2. So I'm still just kind of playing with these as we're working along. Break it down, put them together when we can. So I believe, I'm just looking to see where I got some other ones coming here still. Nope, those are going to combine. Okay. Let's play with one more of the kind of weirder ones. So let's play with this. Let me change colors up here. And again, this is where the note sheet can come in handy. I don't have this posted yet on Classroom. I think I'll do that during my prep period, but I'll freeze this up there in case some of you need to get it here in a bit. So again, just want the stuff that's less than 12. Well, I know 9 doesn't go in, so it must be 4. So 12 divided by 4 is 3. And the 4 is the perfect square. It breaks down. So 2 square root of 3. But that 5's still hanging out. So I'm going to put that there. And multiply the numbers that aren't in radical jail together. Just a process. Now, 75, that's a little bigger. So 75, 64, no, 49. I'm just rolling down these. No, no, yep. 25 and 3. Square root of 25 is 5, or I can do it in my calculator. And just because Hardy unfortunately wrote this way too big, because I got to fit my minus 3 in here, we're going to multiply those together. So 3 times 5 is 15. And fortunately, again, for us, these are the same. If they weren't, I'd be done. But they are, so 10 minus 15 is negative 5 square root of 3. So it really is just kind of working through. And then the last thing, so no even crazy review stuff today. So find a simplified expression for the perimeter of the figure. Okay, so some of them, same thing all the way around. Some of them, kind of the same. You're like, okay, so, So does that just mean I only put the ones together with the same radicals? Yeah. And perimeter, we're still adding. Again, just adding those coefficients that have the same radical. We may not be able to put everything together completely every time. But here's the part that could trick you if you're not careful. The one last one I want to do for right now is number 15. Because it's going to be very easy when you're doing this one to be like, okay, well, Hardy, this isn't bad. I mean, okay, those are square roots of 8, so 3 plus 3 is 6. That's cool. And then these are both square root of 18s, so I just add those up. That's cool. So why did you say this one could be tricky? That looks pretty easy. So here's the thing. When it says find the simplified expression, we've got to check and make sure that those radicals can't break down, because if they can, it's like having the simplified form of a fraction. So let's take a second peek at this one for a sec. Run that by me one more time. Oh, because on this, it's me combining these two. So if I have 4 of these square roots of 5 and 3, I'm just adding those two numbers on the outside, but that stays the same when I'm adding. This one? Why is this 7? Yeah. Because these are both 7. Yeah. If they were all 5, I could have put them together into one term. But yeah, sometimes we're going to get some different ones, kind of like we did here with 2 of them having 8 and 2 of them having 18. But, whoops, I don't want to go so far as off the screen. But I look and I'm like, wait a minute. That 4 divides into 8. So, and again, I just did that one without the calculator, but we can do it with. There it is. So here now, I've got the square root of 4 is 2. Square root of 2, I'm going to start invading the other problem here in a minute. And I can multiply the numbers on the outside. So that one broke down. So I had to go a little further. So I look at this one, and I go, okay. So I look at that, and I'm like, ooh, wait a minute. I think that one has one too. So 18, 6, no, 18 and 9. Oh, 18 and 9. So 9 and 2. The 9 is perfect. So it breaks down to 3, and oh, I'm starting to see it now. Harry, what exactly do you think you're seeing? Well, if I go ahead, and I've broken those down now, I get to this last step, and I'm like, oh, now, didn't that just change things? These both have a square root of 2 now. I can actually combine them together at this point because they have the same radical. 12 plus 24 is 36. Square root of 2. So you're like, all right, if this were a quiz and I put this instead of that, what would happen? Well, this is typically a 4-point question. So you'd probably have 2 here, but another 2 in breaking those down. So you'd have like 2 out of 4. So we always want to check. If I checked 7 and 5, I couldn't break those down. That's why that one was just done when it was. But sometimes you're going to have to go a little further. So I'm just kind of giving you a heads up as you start to look through the rest of these that you might run into a situation that you have to go a little further. Maybe with those, maybe some of them might be. Maybe not all of them, but some of them. So what I'm going to do is I'm going to freeze momentarily the first page of the notes up so you